Good morning, and welcome in the Architecting Enterprise-Ready Networking Solutions in Azure, delivered by the Azure apes. My name is Peter Tander. I'm the founder of Azure Apes, Azure Platform Experts in full, and you can contact me by sending me an email or reaching out on Twitter. I'm a Microsoft Azure architect and trainer, and mainly working on Azure for the last 4 years. I'm also an Azure MVP. In my free time, I keep myself busy in authoring courseware and writing books for PACT and APRESS, for example. In this session, I'm going to talk about Azure networking, starting with a quick overview of Azure networking resources, followed by sharing some Azure networking components, allowing you to build out a hybrid networking topology, and then moving on to some more advanced Azure networking features. And obviously, I'm going to spice up the session by doing several demos. Now, when we look at the Azure networking picture, it obviously starts from the Azure data centers. So all Azure networking features that I'm going to talk about are available in the different Azure data centers all over the world. The core networking starts from a virtual network. A virtual network in Azure allows you to bring your own network, which means that you can define your own IP subnets, IP virtual network settings, bring your own DNS, for example, configuring site-to-site VPN and whatnot, allowing you to control traffic by using a feature called user-defined routes, and I'll talk about that later on. The firewalling security mechanism in between network traffic, virtual networks, in between virtual machines if you want, is defined by using network security groups. When we take a look at what's called the front-end access, meaning incoming traffic from the outside public internet into the Azure virtual networks, Azure provides you load balancing, a couple of different options that I'll talk about later on, allowing you to define public and private IP addresses in a dynamic way or in a private way, where you can define your own IP addresses or relying on Azure Automatic IP Allocation. Azure DNS is nothing more than the typical DNS, but provided as an Azure service. Azure networking traffic has built-in DDoS protection and obviously allowing you by default to directly connect to virtual machines by using the Windows RDP protocol or SSH if it's a Linux machine. Lastly, taking a look at the backend access, it's mainly pointing to virtual private networks, where Azure gives you point-to-site VPN from one individual developer workstation or an admin workstation if you want, connecting to the Azure backend, site-to-site VPN, allowing you to really build out an integration from your on-prem existing data centers or multiple office locations all over the world into the Azure data centers, or the more powerful one, providing you more bandwidth, is called ExpressRoute. And one of the other features that I'll talk about later on is called VNet peering, allowing you to interconnect multiple Azure virtual networks with each other. So in short, Azure provides you end-to-end enterprise-ready networking solutions. For any given example, any given scenario, Azure Virtual Networks and everything that I already covered should allow you to build out enterprise-ready networking topologies. So zooming in a little bit more on the Azure core networking components. From within the Azure data center, within an Azure specific region, the overall image looks like this. It all starts from the virtual network. A virtual network is an Azure networking component in which you define different subnets, where a subnet is obviously an IP addressing space. The 10.001/24.192.168.0/16 and so on. Next to a subnet, you allocate network interface cards. Although a virtual machine cannot really start up or run without a network interface card, nothing blocks you from already pre-allocating network interface cards before actually attaching them to a virtual machine. On another layer, we have external and internal load balancers. An external load balancer is mainly the load balancing provided from the public internet into your Azure virtual networks, where an internal load balancer allows you to load balance network traffic from within a specific subnet. And lastly, already mentioned, site-to-site VPN gateways and network security groups, allowing you hybrid integration from an on-prem data center into the Azure data centers, and network security groups being the mechanism allowing you to really define on a firewall-alike scenario incoming and outgoing traffic to a specific VNet or a specific virtual machine if you want. So drilling down a little bit more, this is just an example of a typical Azure virtual network scenario where we define a specific subnet 10.0.0 something for example, Active Directory domain controllers, and a second separate virtual network and subnet for my web servers. At the same time, we're going to allocate DNS servers. So in short, an Azure virtual network allows you to really isolate your network traffic. By creating subnets, you can isolate traffic between the different subnets, where the security mechanism in between is called network security groups. Whenever you define your virtual networks and subnets, Azure obviously supports static IP addresses. Even although it's not really recommended, but somehow it's technically possible, you could configure your own fixed IP addresses or static IP addresses for your virtual machines. The only true business case where I can see this being valid is, like I show you here, Active Directory domain controllers, where you're specifying Azure DNS pointing to these domain controllers, DNS settings. Internal load balancing is supported, and DNS, there we are again. Cool thing is that it also allows you to really build out hybrid connectivity. So what you do is deploying a virtual gateway configuration like a VPN-alike appliance in the Azure virtual networks, providing you an integration from the Azure networks into your on-prem data center. Site-to-site VPN, point-to-site VPN, and ExpressRoute. It all starts from the virtual networks, where you define what's called an address space. An address space is nothing more than the classless Internet Domain Routing or CIDR notification, which basically points to the 10.0.0/24/16 and so on. Bring your own DNS is fully supported in Azure, which means that by default Azure will provide its own DNS services, but in a typical enterprise-oriented setup where you're really building out this hybrid scenario, most organizations really want to use their own DNS servers, where this could be Windows machines, Linux machines, or even deploying specific DNS appliances in Azure. The only thing you have to do is changing from the Azure DNS settings into custom DNS. So again, can be hosted in an Azure virtual machine, even pointing to an external service, or if you already have site-to-site VPN, it could obviously also point to an on-prem running IP address. The virtual machines are assigned DNS settings during boot time. So one of the frustrating changes, but it's mainly because most customers don't really know about it, don't change your DNS settings directly from within the IP settings on the virtual machine itself, but just point to the DNS server configuration on a virtual network, where by default all virtual machines that are linked to the virtual network settings will pick up the custom DNS and allocate DNS server settings. Any Azure subscription obviously gives you public IP address functionality. A public IP address can be assigned directly to a network interface card or to a load balancer in front of it. It supports static and dynamic assignments, providing also an integration with a DNS label. Like in the example here, I'm deploying a typical Azure load balancer, providing a name called app load balancer. The default name, West US, which points to the region, cloudapp.azure.com. By using CNAME alias, nothing blocks you from really specifying your own custom load balancing.company.com, something like that, where the load balancer in turn is pointing to two virtual machines in this scenario, where again each virtual machine has a public IP address, where this could also point to private IP addresses. And interesting to know, the first 5 static IP addresses are available for free. On the other hand, a couple of words around private IP. A private IP is allocated based on the order of provisioning your network interface cards. The first 4 IP addresses are reserved by Azure. So example, when you create a subnet for web servers, for example the 10.01/24, you allocate the first NIC, it will become the 10.01.4 and the second one 1.5. Now again, this happens during provisioning, which means that if you create the first NIC and you allocate it to virtual machine 2, then virtual machine 2 will receive IP address 10.01.5. Static private IP addresses should be used to retain IP addresses regardless of order. So it's again really up to you to link the network interface cards to the correct virtual machine. So to start up this first demo, let me quickly jump to my Azure portal, where, for example, I can show you a couple of words around virtual networks. So this one is a virtual network running in the central US Azure data center region, where I have 2 network interface cards. And as you can see here, those 2 interface cards, the first one has an IP address 10.02.4 and the second one 10.02.5. For my virtual network, I define my address space, which is 10.02/16 in this example, and I can verify my connected devices, which again are network interface cards. For each VNet, I can define subnets, a single one or multiple ones. Like in this scenario, I'm using my central US subnet 10.02/24, but I also created a central US DMZ subnet 10.03, in which, for example, I would deploy web servers. I talked about DNS servers, where the default setting obviously is using Azure provided DNS, where by switching here to a custom one, the only thing I have to type in here is my custom IP address pointing to my DNS services, which could be the 10.4.8.9 something, not that important. Another interesting feature is diagram, where it's basically showing me the different subnets, and each subnet is also showing my network interface cards. So it's really easy to create new virtual networks or integrating with other virtual networks. So moving on, talking a little bit about Azure load balancers. Azure provides you a couple of different load balancers, where for now I'm focusing on the specific Azure ones, the first one being Azure Load Balancer, literally called Azure Load Balancer. The Azure Load Balancer is what's called a typical load balancing layer 4 and can act as an external or internal load balancer. An external load balancer, again, is the load balancer that's directly connecting to the internet, allowing you load balancing for example, public-facing web servers. An internal load balancer is deployed within a virtual network, allowing you to load balance traffic within a virtual network, or, for example, database servers that are running behind public-facing web servers. An Azure load balancer supports any TCP and UDP protocol. So it's a typical load balancing solution for incoming RDP. For example, if you're deploying remote desktop services or Citrix, web servers, mail servers, any other protocol you can think of. Verifying if the load balancer is operational, and not just a load balancer, but the servers running in the backend, is verified by using what's called health probes, where the health probe can be an HTTP packet verification or a TCP packet, obviously. So a typical enterprise scenario here is using an internal load balancer. So what we have here is a site-to-site hybrid connection from an on-prem data center into the Azure backend. Users are connecting to a web application intranet, which is running on 3 different web servers in the Azure Virtual Network area. To make sure that the intranet is always available, instead of pointing to each and every web server, you deploy an internal load balancer. And obviously the internal aspect means that this load balancer is not intranet facing. On the other hand, you can mix and match external and internal load balancers. So a similar example, web servers running within Azure Virtual Networks, where my users are connecting to a public-facing website called company.com. They point to a DNS public entry, which refers to my public-facing external load balancer. The load balancer in turn provides load balancing for web server 1, 2, and 3. Now in this scenario, web servers are connecting to application servers. Again, application server 1, 2, and 3, where I'm adding an internal load balancer, specifically load balancing the traffic for my application servers. So nothing really blocks you from building out truly intelligent load balancing networking solutions. The second approach is Azure Application Gateway. Azure Application Gateway is another built-in Azure load balancer, providing you some differences with the already mentioned Azure load balancer. The first difference is that Azure Application Gateway is operational on layer 7, which means that it's really recognizing the application IP packets. Application Gateway only supports HTTP and HTTPS traffic, so you cannot really use it for all scenarios. Other aspects are cookie affinity, SSL offloading, and since the latest updates a couple of months ago, it also has web application firewall functionality built in. Other load balancing solutions in Azure is Traffic Manager, which allows you to really load balance traffic between Azure regions. And if you have some limitations in the Azure Load Balancer or Azure Application Gateway, another solution is using third-party provided load balancing functionalities from the Azure Marketplace. For example, Camp, F5, Barracuda, and some other well-known brands in the typical on-prem data center world are available from the Azure Marketplace. Moving on to network security groups. A network security group is really a firewall software-alike solution enabling network segmentation and DMZ-alike scenarios. By using network security groups, you really define incoming, outgoing traffic if it's allowed or denied. From any incoming, outgoing communication to a virtual network, or even down to virtual machine network interface card level if you want. So the core use case for network security groups is restricting traffic from an external or internal source, but only within the region where it was created. So you cannot really use network security groups across different Azure regions. Interesting, management of network security groups obviously is available from the portal by using Azure Resource Manager templates or using command line CLI or PowerShell to really automate your security group management. So again, another example here, what we have is 2 different subnets within one single virtual network, where in this scenario we want to provide incoming HTTP traffic to the web servers, and next to that blocking traffic to my SQL Server backend. So what we're going to do is creating a web security group where we define the source address being the intranet, the port range can be anything, where the destination port is 80 for HTTP protocol, and the destination address is the full subnet for my web servers. Where the second SQL network security group allows me the source address being the subnet of my IIS web servers, destination port 1433, which is a default SQL Server TCP port, and the destination is my SQL subnet. So that's really how you can define your incoming, or if you want, outgoing network traffic. To make the setup complete, there's also a load balancer in front of the web server subnet. So quickly jumping to another demo, walking you through network security group configuration in the Azure portal. So within my Azure configuration, there's a section called Network Security Groups, where in this example here, I defined an incoming HTTPS network security group, allowing me incoming traffic to port 443 from any source up here to my virtual network. So let me quickly add another one. Let's say I want to provide incoming traffic to a specific IP address. Let's say the 10.02.5, which is one of my servers, where the port would be 1433, one of my SQL servers. On TCP level, priority would be 110, something like this. So what this will do is immediately updating my network security group configuration. The rule will be applied as well immediately once it's being created, and at this moment in time I defined incoming traffic to my web servers within the virtual network and a specific one to my SQL server. There's also an option here, default rules, which is also interesting to know, that by default network security groups provide you 3 default settings. The first one, allow VNet inbound from any to any between the virtual network, which really means that all machines, all network cards within the same virtual network can actually communicate with each other. There's another one, allowing Azure Load Balancer inbound, where if you deploy an Azure Load Balancer, it will allow traffic from the load balancer to the incoming virtual network or virtual network interface card. And on the other hand, all inbound communication by default is being denied, which obviously makes sense since it's the most secured configuration. Which brings me to another interesting enterprise-oriented feature called networking user-defined routing. So what default routing means in Azure is that traffic automatically flows between virtual machines in different subnets and within address spaces, where Azure has a couple of default routes available. The first one is routing within a subnet, which means that all machines in the same subnet can actually communicate with each other. This is typical subnetting behavior. Another one is from a subnet to another subnet within the same virtual network. So think back about the previously explained topology, having web servers in a specific subnet, talking to SQL servers in another dedicated subnet, where both subnets belong to the same virtual network, where by default all traffic from one subnet to the other in the same VNet is being allowed. The next one is obviously outgoing communication to the intranet. If you're adding virtual network site-to-site VPN by using the gateway, and virtual network to on-prem, again by using VPN gateways. Now imagine a typical Azure virtual network having 2 subnets, a front end with web servers and a back end with, for example, SQL Server. So knowing the default routing, all communication from the front end to the back end subnet is being allowed, and from the internet, from the front end subnets, outgoing communication to the internet. Now, if you're not really okay with the default routing behavior, then you have to rely on user-defined routing. So user-defined routing really helps you in controlling traffic flow within your network by using custom routes. you can specify the next hop and defining a default route to really force tunneling communication. Where in this scenario, what we're doing is, for example, really blocking or really defining traffic from the front end to the back end that needs to pass through a virtual machine appliance. Could be a jump host, could be a logging station where you really want to find out what communication happens between the front end and the back end subnet. Or in the other direction, not just allowing all outgoing internet to the internet using the default route, but forcing communication through, for example, a proxy logging server by again using user-defined routing. Another scenario is force tunneling. It's a bit similar to user-defined routing, but what we're going to do in this scenario is really forcing redirecting internet-bound traffic to an on-prem site, for example. So imagine we have site-to-site VPN running in an on-prem network and communicating with Azure Virtual Networks, where at some point in time we really want to force internet communication only to the front-end subnet, but blocking internet communication to the backend servers. Or if anyone is trying to connect to my backend servers, for example for remote administration, we're gonna configure force tunneling, where communication first goes to my on-prem network through the site-to-site VPN and then allowing communication to my backend server. Brings me to another feature called VNet peering. VNet peering is a really interesting feature. It basically allows you to connect two virtual networks within the same region. VNet peering communication happens on the Azure backbone network, so not like in some other public cloud scenarios where traffic goes through the public internet. By interconnecting VNets by using peering, they appear as one larger network, but they still remain separate resources. From a virtual machine perspective, the experience is exactly the same, providing the exact same throughput for peered VNets as they would belong to the same virtual network. So an interesting case here is using multiple virtual networks for example, segregating billing or segregating admin between an Azure virtual network, where again for now an Azure virtual network cannot span multiple subscriptions. The true benefit of using virtual network peering is really relying on the Azure high bandwidth connectivity between multiple VNets, giving you the ability to use resources across multiple VNets, where a typical business case the last couple of months is really integrating resources from an Azure Classic model into Azure Resource Manager. Now, quite important to keep in mind, imagine you have three different virtual networks where you define peering between virtual network A and B and a second one between B and C. It doesn't mean that VNet A can automatically communicate with VNet C. This would require an additional peering communication. Quickly showing you what this looks like from the Azure portal. Going back to my subnet configuration, selecting the peering option here, where this one could be peering to Classic, doesn't really like it here, but imagine you have, oh, let me go back to my other VNETs. This one is actually pointing to another region, that's why it's giving some strugglings. Peering to Classic. Now again, it's not just for Classic, but just a typical enterprise use case where down here I can select my Classic VNet, confirming, and what happens now is a direct communication from my Azure Resource Manager VNet 10.0 something into my already existing Azure Classic VNet, where from here on virtual machines from one Azure Resource Manager VNet can directly communicate with virtual machines running in the Azure Classic VNet, allowing me to migrate virtual machines, migrating data, and so on and so on. So pretty interesting feature. Last couple of minutes, I want to talk about networking monitoring and troubleshooting. The first component available in Azure is Azure Network Watcher. Azure Network Watcher is a pretty new feature in Azure Components, giving you a lot of interesting options. First of all, providing you a topology view, allowing you to inspect network traffic by using a variable packet capture, where maybe some of you were using Wireshark in the past to really troubleshoot network communication, where Azure Network Watcher is basically providing you the same thing. IP Flow Verify is a nifty feature allowing you to test out IP communication from, for example, one virtual machine to the other, providing you VPN diagnostics, network security group flow logging, and a lot of other features are available. The second one that's built in the Azure subscription is called Azure Network Monitor. Azure Network Monitor is a centralized hub allowing you to really monitor different Azure resources based on alerts, metrics, integrating with log analytics, service health, application insights, and also having a pointer to the already mentioned Network Watcher. The last one, not really specific to networking, but in meantime providing some specific networking security features, is Azure Security Center, which again is a centralized dashboard focusing on security posture of Azure, and not just Azure but also hybrid systems and applications. By design, it's active in 3 different areas, providing you a general security view, giving you a security state view of your virtual machines, networking, patch level, and so on, but also pointing to prevention and detection. And specifically around networking, it's giving you networking recommendations, internet-facing endpoint security views, and a network topology security view. So showing you those options from within the portal, let me start with Network Watcher. Where the first thing you have to do is enabling it for your specific Azure region. And once it's being enabled, you can use any of those diagnostic tools. So for example, IP Flow Verify, allowing you communication from one virtual machine to another. So let's say from one machine to DNS. Why not using DNS? And checking the verification, where after only a couple of seconds it will show me if traffic is being allowed or not. So for now it's being denied because I'm having my network security group being kicked in, where the default inbound communication from my public DNS into my internal local IP is being blocked. Obviously, if I change this to outbound verification from my local Azure virtual machine IP to the public Google DNS, obviously that one will be allowed. I don't really have the time to drill into the other features, but keep in mind Network Watcher, really interesting. And lastly, Security Center. Zooming in on the networking aspect. It's giving you an immediate real-time view on your security posture of the networking. So for example, for my endpoints, my 3 virtual machines are public-facing connections where I'm not using a network security group for now. And that's being flagged as a security risk, obviously. Within my network topology, it's recognizing again my different VNETs and again pointing to not having network security groups available. Where just by selecting any of those remarks, it's immediately jumping to, hey, watch out, you should enable your network security groups. And if I already have them, I can select any of those if obviously their configuration is valid for my virtual machine traffic. So that's in short Network Watcher, Network Security Center. So with that, I walked you through overall Azure networking resources, walked you through building out a hybrid network topology, and walked through a couple of advanced Azure networking features, and in between doing some demos. This was the Architecting Enterprise-Ready Networking Solutions in Azure, delivered by the Azure Apes.